For question number 8, I need to find the acute angle between the line y equals to 3x and the x-axis. All right, so when you're dealing with an acute angle, this is going to be definitely less than 90 degrees. And since we're dealing with the line y equals to 3x, let's go ahead and sketch a little graph here. Here's my xy axes, and here is the equation of my line or my graph here of y equals to 3x. And this is your x-axis there. So if you had to go ahead and construct yourself a triangle here, the question is, what is this angle right there? Okay, so let's take a look at this equation right here, y equals 3x, and I know the slope is 3, but it's really 3 over 1, right? So the rise is 3 and the run is 1. So how does that translate to the graph over here? Well, this height is going to be 3, and this horizontal distance is going to be a 1. So this horizontal distance right there has a value of 1. All right, so now we can use a trig ratio to find that missing angle. Now, with respect to that missing angle here, the 3 over here, that's your opposite. And the 1 that's right next to the angle, this is your adjacent. Okay, so the trig function that relates the opposite and the adjacent is the tan function. So this would be tan of theta. And this is going to equal to the ratio of the opposite over the adjacent, so this is 3 over 1. Now, if you want to get the theta there, you would do the second inverse of tan, so it would be tan inverse 1, and on your calculator you would input 3 over 1, or just 3, and then once you hit the equal button, your angle that you should get is about 71.6 degrees. And that's how you do question number 8. Okay, so move on to question number 9 here. All right, so for question number 9, I have 200 meters of string is used to fly a kite. An angle of 37 degrees is formed with the person flying the kite. If the person is 2 meters tall and the string does not have any slack, how high in the air is the kite? Okay, so for this particular problem, I might as well go ahead and draw a right angle triangle, and then we'll label the triangle together in a bit, or we'll complete the triangle in a little bit here. The kite could be around here, and this green distance right here, that's the length of the string of the kite, so that is 200 meters. Okay. And the angle that we're given this problem is 37 degrees, so 37 degrees will be right in the corner there. And the person, if the person is 2 meters tall, so I'm assuming that the person is just right underneath the string right here. And what we're just trying to say here is this person is 2 meters tall. 2 meters tall there. And the question is, how high in the air is the kite? So we need to consider this purple distance here, and we also need to consider the height of the person, which is an additional 2 meters right here, right? All right, so let's label this purple part as x, and let's find the value of x, and then we'll add 2 more meters to that, and that should give you how high in the air the kite is. All right, so going to my diagram here, with respect to 37 degrees, the x right here, this is going to be your opposite. And the 200 meters, if I go directly across the 90-degree box here, this is your hypotenuse. All right, so the trig function that relates the opposite and the hypotenuse is sine. So I need sine of 37 degrees. That equals to your opposite, which is x, divided by your hypotenuse, which is 200. All right, so there's my trig ratio there. And now I need to solve for x. And for this part here, all you do is you take your 200 and you multiply that with sine 37. So it'll be 200 times sine of 37 degrees, and that equals to x. And then go to your calculator, 200 times sine of 37 degrees will give you 120.36. And then after that, you'd add the additional 2 meters, and your final answer should be 122.36 meters there. So that's how high the kite is above the ground. Okay, let's move on to question number 10 here. So what angle will a 190-foot wire make with the ground if it is used to support a transmission tower of 120 feet high? Okay, so step number 1, let's go ahead and construct our little diagram here. So right angle triangle. Since the tower is 120 feet high, I'm assuming that this right here represents the tower. That's 120 feet. So this blue distance right here, that's the height of the tower. And what angle will a 190-foot wire? Okay, so this part right here, the wire, right? So the wire has to be this part right here, right? That's the wire, that's 190 feet. and I need to find this particular angle right there. Okay, so not a tricky problem to set up here. Just make sure you complete your diagram and then find the right trig ratio here. Okay, with respect to this angle here, the 120 degrees is your opposite, and the 190 here is going to be your hypotenuse. Okay, so the trig ratio that relates hypotenuse and opposite is going to be the sine function, right? So this would be sine of the angle, and the angle we don't know, so we'll label that sine theta, and that's going to equal to the opposite, which is 120, divided by your hypotenuse, which is 190. All right, so from there on, you would go to your calculator to find the missing angle, and you would write in the, you would input the inverse of sine, and the inverse of sine of 120 over 190. And once you do that, you get an answer of 39.2 degrees. And that's your final answer for number 10. Okay, let's go on to question number 12 here. Okay, for number 12, to estimate the distance across a river, John sighted a rock directly across the river. He then walked 40 meters downstream and estimated the angle between the riverbank he was on and the rock across the river to be 27 degrees. Find the approximate width of the river. Okay, so do take a little bit of time to kind of read through this problem to kind of figure out what's going on. Let me go ahead and draw my diagram for this problem here. So I'll have one side here and one side there, and for sure this will be my river. So maybe John is about here initially, and maybe the rock is over here. Okay, now he then walked 40 meters downstream. So let's just pretend John goes downstream. So let's say he walks down here. Let's just say that John is now here now. I have a blue mark there. So John is right there. And then he estimates the angle between the river bank he was on and the rock across the river was 27 degrees. All right, so let's take a look at this part here. The river bank that he was on and the rock across the river was 27 degrees. So if I draw a little angle right here, since this part right here is the river bank, what that means is this angle right here is going to be 27 degrees. All right, so the question says he estimated the angle between the river bank he was on and the rock across the river to be 27 degrees, right? So since the river bank is right here, this has to be 27 degrees. Okay, so now you know that, you can just draw a little triangle across the river here, and we know that this distance right here in green is going to be 40, and we also know that this angle right here, that purple angle, is going to be 90 minus 27, which is going to be 63 degrees. And our goal now is I need to find the length of this black horizontal line right there, which I'll label X. So that's how you label the diagram for question number 12. Okay, so then from here on, it's not too bad. With respect to the 63 degrees, the 40, this is your opposite. And the X right here, this is your adjacent, right? So the trig function you're using is going to be the tan function. So tan of 63 degrees is going to be your opposite, which is 40, divided by your adjacent, which is X. And then from here on, you would just solve for this by interchanging the tan 63 and the X. You can just switch those positions. So X would equal to 40 divided by tan 63. And if you do the math there on your calculator, you should get about 20.4 meters. All right, so 20.4 meters is the answer for number 12. Okay, let's move on to question number 15 now, the last question in this homework video guide. So for number 15, I'm given the equal sides of an isosceles triangle measure 46 centimeters and the equal angles measure 58 degrees. Okay, so if I draw a equilateral triangle, an isosceles triangle here, we're given that this is going to be 46 centimeters, and that means that this has to be 46 centimeters. And the equal angles are going to be 58 degrees. So this is 58 and that's 58. All right, so we know angles in a triangle add up to 180. So if you want to go ahead and find that top angle, you can do that. And that's going to be about 63 to 64 degrees right there. All right, so for part one, I want to find the height of the triangle. Okay, so if I actually redraw this triangle right here, I can cut in half. All right, so I know this is still going to be 46 and this is going to be 58. And I want to find the height, which is right here, right? That's the height right there. All right, so since this is a right angle triangle now, we can set up our trig ratio here. So with respect to 58 degrees, the height is my opposite and my hypotenuse is 46. So the trig ratio that connects the opposite and the hypotenuse is going to be the sine function. So sine of 58 degrees equals the opposite, which is your height, divided by your hypotenuse, which is 46. So now your height would equal to, you take your 46 and you multiply it with your sine 58. So it's going to be 46 times sine of 58. And let me just quickly do that on my calculator here. 46 times sine of 58, that's going to be 39.01. So 39.01, and it'll be centimeters. So that's the height of that isosceles triangle. All right, the next question is find the length of the base of the triangle. All right, so using the same triangle that I had for part A, I know this is going to be 46. This is going to be 58 degrees. How about this time we find the value of x over here? And once we find that value of x, we can double it to get the entire base, and that will be the length of the triangle there. Okay, so the x right here, that's your adjacent, and your hypotenuse is 46. All right, so which trig function relates hypotenuse and adjacent? That's going to be the cos function. So it'll be cos of 58 equals to your adjacent, which is x, divided by your hypotenuse, which is 46. So x will equal to 46 times cos of 58 degrees. So 46 times cos of 58 degrees is going to be about 24.376. And then if I times that by 2, remember we have to times it by 2 because we still have the other length of the triangle to consider, right? So that's why we need to double that up. And that should give me about 48.8. So x will equal to 48.8. And the units here are going to be centimeters. Okay, the very last question is find the area of the triangle. Okay, so if you're given the triangle here, I know the base is going to be 48 point, it's a little bit thick there. It's going to be 48.8 centimeters. And I know my height, based on part A, is going to be about 39.01. And if I want to find the area, that's going to be your base times your height divided by 2. So my base is going to be 48.8. My height is going to be 39.01. You multiply those together and you divide by 2, and that will give you the area of the triangle. And roughly you get about 951. 951, I get 951.8 centimeters squared. So as long as you're close to the answer here, sometimes the answer varies depending on how many decimal places you carry over. So as long as you're close to 951, that would be the correct answer. All right, so that concludes this homework video guide.